In this video, we're going to be comparing the M1 Pro chip against the upgraded, more expensive M1 Max. We're going to be seeing if those extra CPU and GPU cores make a difference, how hot the M1 Max gets compared to the M1 Pro, battery life, RAM usage, and finally, if the extra $500 price tag is worth it. Now, I will also have the timestamps down below so that you can skip to a relevant section. But for now, as you can see, both of these devices are at 100% battery life, and I'm going to unplug both of them. And at the end of the video, we're gonna see exactly how much percentage is left and which of these machines is actually the better battery performer. Now you'll notice that this only has 16 gigabytes of RAM versus 32 gigabytes of RAM. I will be doing a video where I upgrade this model to 32 gigabytes so we can get a more accurate comparison. But the purpose of this video is just to see if it is worth going all the way from a base model 14-inch M1 Pro to the base model M1 Max that obviously starts at 32 gigabytes of RAM. So first things first, let's start with the price difference and also what exactly you get with the M1 Max over the M1 Pro. So the M1 Max is an additional $900 more expensive than the base model M1 Pro. You also get the 96 watt charger instead of the 67 watt charger, and you get an additional 2 CPU high performance cores, giving you a total of 8 high performance cores and 2 high efficiency cores. You also get an additional 10 GPU cores, so 14 on the standard M1 Pro and 24 on the base model M1 Max, but obviously you can configure that up to 16 and then up to 32. But in this video, we're just comparing the base model of each version. You also get increased memory bandwidth speed. So the speed has actually doubled from 200 gigabytes per second to 400 gigabytes per second. Now, some people have asked me what exactly this means, and a really simple way of putting it is just how quickly the system can communicate with itself. When upgrading to the M1 Max, you also get double the video encode and decode engines. And of course, you get 32 gigabytes of RAM as standard on the Max chip versus just 16 on the M1 Pro. Okay, so let's do some performance benchmarks. Hopefully we can see some differences between the two. In terms of physical differences, there are none. All the differences are actually under the hood with the actual chips themselves. Now, quick FYI, I'm on the most recent and up-to-date version of macOS Monterey on both devices. Okay, so let's see if there's any difference in internal SSD speed. Now, there shouldn't be, but I'm just running a Blackmagic disk speed test here to double check. As you can see, they're both pretty much identical within the margin of error, so I'm pretty confident in saying that there really isn't any difference. This is obviously the same 512 gigabyte SSD on both models. So moving on to CPU, let's run a Geekbench 5 CPU test to see if we can find any difference. Now remember, the only difference is that this machine has an additional 2 performance cores over the base model M1 Pro. So Geekbench 5 has finished and we got 1769 for the single core score on the M1 Pro versus 1787 for the single core score on the M1 Max. For multi-core, 9,938 on the M1 Pro versus 12,683 on the M1 Max with the additional 2 high-performance CPU cores. So as you can see there, not a massive difference, about 15 to 20%. So while we're still in Geekbench, let's test out the GPU. So I'm gonna run the Metal Compute benchmark. Okay, so the GPU benchmark has finished. We got 38,390 on the M1 Pro versus 59,960 on the M1 Max. So that score is about an additional 55% more powerful than the M1 Pro. So moving on to Cinebench, this is gonna give us a more realistic idea, the difference between the CPUs, because obviously it's gonna put it through a bit of a stress test, gonna be some thermals involved. It's longer than Geekbench. So we're gonna come over here and we're going to start the multi-core test. So we'll come back in a couple of minutes. I will test the internal temperature of the CPU, and I'll also do the FLIR thermal test to see how hot the exterior gets. Okay, so we're about halfway through the benchmark, and I just wanted to talk briefly about fan noise between the two. So the M1 Max's fans are audible. They're not super loud, but you can hear them. They've definitely kicked on before the M1 Pro. If we have a look here, the fans are at about 3,900 to 4,000 RPM versus on the M1 Pro, they're only at about 2,500 RPM. So that is a fairly big difference, but we'll come back to this in a second and check it out again. Okay, so Cinebench has been running for about 8 minutes at this point. Let's have a look at the temperature of the cores. So as we can see here on the M1 Pro, we're sitting at about 95 degrees Celsius on average between the high performance cores. And as you can see there, the average CPU temperature is about 91 degrees Celsius versus a little bit hotter. So you can see the average temperature of the cores around 95, 96. These are obviously the performance cores. And then we have an average CPU temperature of about 94. So about 2 or 3 degrees Celsius more than the M1 Pro. Now, moving on to the thermals of the exterior chassis, you can see that the M1 Max actually seems to have the larger thermal profile. So if we come close to the M1 Pro, we can see right in the middle there at the hottest part, we're getting about 45 degrees Celsius. And then on the palm rest and trackpad, about 31 degrees Celsius versus the M1 Max. We're looking at about the same, about 44 degrees Celsius right in the hottest part. And then on the trackpad, about 31, and then also on the palm rest, about 32. So it looks like, at least from an external chassis point of view, they're both about the same temperature. But again, guys, as you can see, the fan RPM is at about 4,200 on the M1 Max versus about 2,800 on the M1 Pro. So that's a fairly significant difference. And it obviously just means that the fan is keeping this chip a little bit cooler because it's running hotter. But again, guys, in terms of fan noise, at least with just CPU intensive tasks, it's really not obnoxiously loud at all. You can barely hear it. But that being said, the M1 Pro is almost near silent. Okay, so the Cinebench benchmark has completed. As you guys can see there, the single core score is essentially identical between the two, but the multi-core score, we got 9,544 on the M1 Pro versus 12,352 on the M1 Max. And that is a difference of about 30%, which again, isn't massive, but if you're doing a lot of CPU intensive tasks, that can start to add up over time. So moving on to Lightroom. Lightroom is traditionally CPU and RAM intensive, so hopefully we should see a difference here as well. So as you can see, we have 50 24 megapixel raw photos of the created cat. So let's just import all of these. And as you can see, we're having no issues at all swiping through them. Seems to be really smooth, and I can't really tell a difference between either machine. Let's move on to exporting these photos. As you can see here, I'm just gonna hit the export button, gonna start the timer, and we're gonna see how long these two take. And the export has finished, and as you can see, only a 3-second difference between the two. So let's move on to video encoding. This should hopefully give us a more real-life example of the differences between these CPUs. Now, as you can see here, I have Handbrake open. I've selected a 2-minute clip from my Sony a7S Mark III camera, so it's already very compressed 4K footage. I'm using the fast 1080p 30 preset here to encode this particular clip. So let's click the start button up here. Okay, so we have about 20 seconds left. As you guys can see up here, both of the CPU cores are getting pretty toasty. Not as toasty as before, but they're up to about 80, 90 degrees Celsius. We are just about to finish encoding on the M1 Max. We've got 3, 2, 1, and we are done. And then on the M1 Pro, we've got about 5 seconds left. So this is gonna be a very close call. And that is done as well. So we have 3 minutes and 30 seconds on the M1 Max versus 3 minutes and 39 seconds on the M1 Pro. And to me personally, that's really not a massive difference at all. Okay, moving on to some 3D modeling and animation. We have Blender here. As you can see, we're in the wireframe view. We are using the Party Tug 6 AM test scene. Switching between the different viewports here. You can see they're quite responsive. If I now play in this particular viewport, you can see we're getting actually double the FPS on the M1 Max. So we're getting about 9 FPS versus about 5.5 FPS. If I now pause both of these and we change to the rendered view, as you guys can also see, we are using the EV render engine. And if I now play this one as well, Again, getting the same kind of performance difference. This one seems to be 10 FPS quicker. Okay, so let's render out a scene. You can see we are on frame 0. This is also the M1 optimized version of Blender. It's not the previous Intel version. So I'll come up here to render and we're going to render image. And on the M1 Max, we got 6 seconds and 49 milliseconds versus the M1 Pro, which was slower at 9 seconds and 87 milliseconds. All right, moving on to Splash Fox. Let's just play this first of all. As you can see in the shaded view, both playing back relatively easily. If we move up to the next view, you can see again, we're getting a higher FPS playback on the Max. We're getting about 4.6 FPS versus 2.4 on the M1 Pro. Now, as you can see on this particular scene, we are using the EV render engine. And what I'm gonna do now is I'm going to come over and I'm going to render out 30 frames on each device. And we're gonna see how long it takes. And we're also gonna check out the CPU, RAM, and GPU usage during the render. Okay, so I've hit render animation, also going to start the timer. We are about halfway through the render. As you can see on the Max, we're at frame 21 versus frame 15 on the M1 Pro. Now, looking at the memory pressure chart, you can see that both devices are maxing out the GPU, which is to be expected. This is an EV render. And then looking at the activity monitor, you can see Blender is using about 13 gigabytes of RAM on the Pro and actually a little bit less on the Max. But overall memory pressure, as you can see there, is a lot lower on the Max. You barely have anything at all, whereas it is starting to get a little bit high on the Pro. So you can definitely see where the difference in RAM can come into effect. So if you're multitasking more on this device, you might struggle, whereas this, you have more headroom. Okay, and we are now at frame 29 on the M1 Pro. We're just about to finish. There we go. Okay, so we have a final time of 5 minutes and 15 seconds on the M1 Pro versus just 3 minutes and 51 seconds on the M1 Max. So we're really starting to see a significant difference between the two here in terms of GPU cores. Obviously, this does have the 10 extra cores. And you can imagine if you are doing an hour-long render or a 2-hour-long 3D render, that time difference can really start to stack up. Okay, moving on to some editing. I have DaVinci Resolve here. This is the most recent Apple Silicon optimized version as of the date of this video. I have some red raw 8K footage here, which is typically not only difficult to edit, but also just to play back on both systems. So as you can also see, if we come into the timeline settings, we have the timeline resolution set to 4K. Now again, typically most people wouldn't edit in a 4K resolution while they're editing their project. They'll bump it down to 1080p, for example. So let's play this and see what kind of FPS we're getting. So not the greatest. You can see we've only just gotten green on the FPS counter. It seems to be a little bit choppy here. This scene is playing back okay. The shark scene is playing back okay too. If we do some scrubbing on the Max, definitely getting quite a few dropped frames. You can see it's not super smooth, and it looks like we're gonna have the same experience on the M1 Pro. Okay, let's drop the timeline resolution down to 1080p. So 1920 by 1080p. Save and save. I'm gonna go back to the start, going to play. And as you guys can see, much better here. So we're getting that little green FPS counter, which means we're getting a full frames per second from the video. It's playing back, no stutters, very smoothly. As you can see there, playback is much, much better than before by simply dropping down that timeline to 1080p. And on the shark scene, works perfectly fine. Okay, so scrubbing on the Max, still a couple of dropped frames. Not as much as before, but definitely not perfectly smooth. And that's about the exact same between the two. I can't notice any difference. Now let's render out this red footage. It's just the 4 sample clips from the red website if you want to do this test yourself. So it's only about 25 seconds of footage, but let's click render all and see what kind of differences we get between the two. So the render has completed. You can see the M1 Pro took 1 minute exactly to finish the render, whereas the M1 Max took 47 seconds to finish the exact same render. Now, I was just using the default YouTube 4K render settings. So that is a fairly big difference in my opinion. And remember guys, if you extrapolate these results out, so say for example, you have a 20-minute or 40-minute render instead of a 2-minute render, that's potentially 15, 20, 30 minutes of render time you're saving with the Max chip. Okay, let's try some different types of footage out. So I have some Sony a7S Mark III footage here, 4K, 10-bit, 422. Basically, some of the best footage you can get from a relatively entry-level pro camera. And I'm gonna put the exact specifications of this footage up on the screen right now if you're interested. As we can see here, we're playing back in 4K on both timelines. Perfectly fine. Now, as you guys might already know with Sony codecs, they're very compressed. They can be very difficult to play back. So the fact that this is playing back quite smoothly is pretty impressive. As you can see by scrubbing this footage, I'm getting a couple of dropped frames here or there, nothing serious. Apart from that, it's 99% smooth. The M1 Pro is almost exactly the same. If I had to choose one, I would go with the Max. I seem to be getting maybe just a few more dropped frames on the M1 Pro. Okay, so let's just quickly zoom out here so you can get a better look at the timeline. As you can see here, this first clip is 2 minutes long. We're gonna come up here and we're going to add a stabilization effect to this clip. So let's hit stabilize on both of those clips. I'm gonna start the timer and we're gonna see which one finishes first. So the results are in, and the M1 Pro finished in 1 minute and 89 milliseconds versus the M1 Max, which finished in 43 seconds and 36 milliseconds. So again, not a massive difference, but if you're sitting here waiting for your clip to finish stabilization, those seconds can really start to add up over time. So what we'll do now, let's jump into the render tab and let's see how long this 6-minute timeline is going to take to render out. Again, just using the default YouTube 4K template here. So just quickly while the render is going, I've pulled up the activity monitor. As you can see here, we're both using almost the exact same RAM between the two. So about 12.5 gigabytes on the Max and about 10.2 gigabytes on the 16 gigabyte M1 Pro. So really not a massive difference. You can see DaVinci itself is using about 4.5 to 5 gigabytes each. So it doesn't really seem like the extra RAM is really being taken advantage of in Resolve as of this point. It looks like mainly the GPU cores are having the biggest difference. So the render has finished. The M1 Pro finished the render in 3 minutes and 10 seconds versus the M1 Max 1 minute and 41 seconds. So the Max finished this render, which was about 6 minutes of really high quality 4K Sony a7S III footage in almost half the time it took the M1 Pro to render. Now moving on to some Final Cut Pro, and this is where I wanted to test out the difference between the doubling of the video encoders and decoders on the Max over the M1 Pro. So I have some ProRes footage here. It's 5 minutes, it's 4K, basically max settings you can get 422, and I have them obviously on both devices here. Playback is gonna be buttery smooth, guys, as you can see here. It looks like I've got about 6 different arms, it's so quick. So I'm not gonna be testing out playback because if you're using ProRes on a Final Cut Pro on these new Macs, your experience is gonna be really good. I mean, even if you've got 4 different streams of 8K footage in ProRes, it's gonna be totally fine. What I wanna see though is the render times between the two, because obviously as a ProRes codec, you're going to benefit from those inbuilt encoders on the M1 Pro and M1 Max chip. All right, so let's come up here and render this out. So I'm going to change the settings. We're actually going to render it out in H.264. So we're essentially going to be changing the codec from obviously ProRes into a more compressed codec. So let's go next. So we have 2 minutes and 30 seconds for the M1 Pro and 1 minute and 31 seconds for the M1 Max. So let's move on to some more gaming oriented tests, and this will hopefully allow us to see a bit more of a difference between the GPUs. So with this first test, I'm going to run the Aztec Ruins high tier benchmark on GFX Bench. Looking at the results, we can see we got 93 frames on the M1 Pro versus 120 frames on the M1 Max. Now again, this has 14 GPU cores versus 24 GPU cores. Now, to get a little bit of a better real-life understanding of what the difference in GPU cores means, let's run a Tomb Raider benchmark on these two devices. Now, Tomb Raider is not optimized for this particular Mac. It's also running on Rosetta 2, so it's basically being emulated. But like I said previously, both these machines are the same. The only difference is the chips inside. So we can see the resolution here, and everything, including the monitor refresh rate, is the exact same. If we come up to graphics, everything's set to the highest setting. So Ultra, BTAO, and everything else is exactly the same. So let's run this benchmark. And as you guys can probably hear in the microphone, there is some fan noise. Looking at the M1 Max, we're sitting at around 6,000 RPM average between the two fans versus the M1 Pro around 4,700. So they're both going to be audible, but in person, I can tell you the M1 Max fans are quite a bit louder than the M1 Pros. The benchmark has finished, and on the M1 Pro, we average about 43 frames per second versus the M1 Max 69 frames per second. So after all of these tests, multiple hours of benchmarking, editing, Handbrake, encoding, and 3D modeling, what is the battery life percentage on these two models, and how do they differ? Now, quick note, I've had the brightness settings at the exact same on both devices, and also Wi-Fi, everything is set up exactly the same. So looking at the M1 Max, first of all, we have 46% battery life. And then looking at the M1 Pro, we have 49%. So after multiple hours of benchmarking, there's probably less than a 3% difference in battery between the two. And it does make more sense that the battery is going to be slightly less on the M1 Max because it's more powerful, the fans are running quicker, but only 3%. I honestly thought it would be a lot more than that. So yeah, that's honestly almost the exact same between the two. So what do all of these tests mean? Well, starting with the CPU, yes, you do get the extra CPU cores. So on paper, it's around a 20% increase you should be seeing, but it really depends on the tasks you're doing. So in Lightroom and Handbrake, for example, we really didn't see a massive difference. Now the GPU, however, we did see a big difference of at least 40% in most tasks. Now you're going to see the biggest difference in 3D applications like Blender. Playback is going to be smoother, and rendering 3D scenes is going to take less time. And don't forget editing. So as you saw when we were adding stabilization effects to videos, we're seeing at least a 50% reduction in time on the M1 Max compared to the M1 Pro. Rendering, we saw massive differences there as well, over 50% in some cases. Now the doubling of the video encoder and decoder chips on the M1 Max obviously contributed to this, but I think honestly, it's mainly the GPU cores is where we're going to be seeing the biggest difference between the two. One thing to mention is also virtualization. So if you're a person to use Parallels or something similar, don't forget that if you do go for the higher spec M1 Max, you can allocate more CPU cores, way more GPU cores, double the RAM, for example. So you're going to see a massive performance difference between the two. Again, this does depend on what exactly you're doing inside your virtualization software like Parallels. If you're doing lots of intensive tasks like gaming or 3D modeling or something like that, I would definitely get the Max in that situation. So let's say you do decide to go from the Pro to the Max. What are the trade-offs you can expect? Well, there's three main trade-offs. Number one, the price tag. It's $900 US to go from the base model M1 Pro to the base model M1 Max. You'll also see a slightly increased fan noise level on the Max compared to the Pro. Not obnoxiously loud, but definitely more noticeable than the Pro. And you'll also see about a 5% difference in battery life, assuming you're doing intensive tasks like 3D modeling or rendering. If you're just using it as a normal everyday machine, web browsing, emails, I think the battery life is going to be pretty much exactly the same. So is the M1 Max worth an additional $900 US? I think for 95% of people, it is not. I think the only people that are going to benefit from the increased power of the Max chip are those that are actually going to use it and those that can afford that extra money to get that little bit more performance out of their machine. So if you're editing on this all day or you're running a business off it, sure. But I think for 95% of people, this is just already such good value, and I just don't really see the extra performance gains being worth the price tag. Anyway, guys, thanks for watching this video. Any questions or comments, you know what to do. Apart from that, I'll catch you in the next one.